All right, let's get started. So let's take a look at number one. So we've got the price of product X. So what I'm going to do is, as I read this, I'm going to write the sentences, like the mathematical equations out to represent the sentences. So the product X is 25% greater. A 25% increase, we use the decimal 1.25 than Y. And the price of product Z is 25% less. Well, 25% less, we would use 0.75 because if we take away 25%, we keep 75%. And then what is the ratio? Well, the ratio is just a fraction. So the ratio of X to Z, and then I'll just replace it with this 1.25Y over 0.75Y, cancel the y's, and then I just need to convert this to a fraction. You could just multiply by 4, or if you don't see that, just throw it in the Desmos or a TI-84 and convert it to a fraction, and you will get 5 to 3, which is D. All right, on to number two. So Sim spent 76 more percent on groceries in 2006 than in 2015 and spent 145% more in 2017. Okay, if Sim spent P times as much. So basically, if we start at whatever they spent in 2015, let's call that X. When you spend 76% more, that's 1.76. Again, that's 1 plus 0.76 because it's more. Now she spent 145% more. Now this is where you got to be careful. We are doing one plus, so let me recap this one. This as a decimal is 0.76, and then we added it to 1. This as a decimal is 1.45, but we got to add it to 1 for the increase. So that's 2.45 is what we have to multiply by. And then it just says P times as much on groceries in 2017 and 2015. So that's P is just whatever these two numbers are multiplied together, right? So starting amount times P gives you final amount. So I'm just going to multiply them together. So if I do 1.76 times 2.45, I get 4.312, which is answer choice D. So it's all about percent increase and decrease, what perspective we look at that from. All right, on to number three. So we got 200 bacteria initially. So anytime we're talking about percent increase or decrease, this is going to be an exponential model, which is typically AB to the X. So my A is the initial amount, and then B is going to be my percent change. So the number of bacteria increases by 10%. So that's being multiplied by 1.10. Now they kind of throw us through a loop, though. So in the first hour, right, that's what they did. But then for each subsequent hour, so we actually have a second one. So this is what they did for the first hour. Then the number of bacteria increases by 5%. So we have another one of these. So they kind of, it's not just this, it's this for the first hour and then this for every other hour. All right. Now let's be really careful here. There's going to be an exponent that I put up here. It says how many bacteria will be in the culture after 8 hours. Well, let's remember we did this the first hour, so then it's only this one for 7 hours, not all eight, because in 8 total hours, it increased 10% the first hour and then 5% for each of the 7 hours after that. So this is how we kind of modify this. So I'm just going to do it in the calculator. So 200 times 1.1 times 1.05 to the seventh. And we get 309.6, which rounds up to 310. All right, that's a pretty difficult problem. All right, let's move on to number four. So he sends out a newsletter once a month. He had 3.4 times as many subscribers as he did in June. What was the percent increase? Okay, so here's really important thing. What we did before was we converted it to a decimal and we added it to 1 for percent increase. Now we have to work backwards. So we should start this, we should subtract 1, and that gives us 2.4. And then to convert it to from decimal form back to percentage form, you multiply by 100. So that gives us 240%. All right. So it's really important that we understand that the after the percent increase has been done and it's in decimal form, that one is included in there, so we have to take it away. So 3.4, while a lot of people might put 340%, multiplying by 3.4 is actually a 240% increase. Whoops. All right, now we go to this section of it. I wanted to go over conversion factors and unit conversions. And I like to use dimensional analysis. So there are 640 acres in 1 square mile. The area is increasing at a rate of 4 acres per year. Which of the following is the closest to the rate at which the area is increasing in square kilometers per year? So right now it's increasing at a rate of 4 acres per year. And we want to change this to square kilometers per year. Okay, so the per year just stays the same. And we know that there are 640 acres in 1 square mile. So what I'm going to do is I'm going to put the acres on the bottom and put the square mile on top so that the acres cancel. So if I ended the problem now, I would have square miles per year. But I don't want square miles per year. I want square kilometers per year. Well, this is extremely important. The mistake that's usually made is students will just do 0.62 miles for 1 kilometer. But the problem is miles don't cancel with square miles. I need them to be squared. So what you do is you just square the whole conversion factor. You square miles, you square 0.62, you square kilometers, and you square 1. But 1 squared is just 1. All right. So if you just square the conversion factor, that's the actual conversion factor that we're using. So what we're going to do is I'm going to do 640 times 0.62 squared, and then I'm going to do 4 divided by that number. Because in the numerator, I have 4 times 1 times 1. That ends up giving me 0.0163, which is answer choice D. All right, number 6, we got another one with square miles. So we got 11,863,808 square yards. And we want it in square miles. So this one's a little more straightforward, but again, you got to be careful of the mistake that's typically made. So we have 1 mile is 1,760 yards, but we want square miles in square yards. So I'm going to put yards on the bottom so they cancel with this, really square yards. So that's 1760. Whatever that squared is, that's how many square yards would be in 1 square mile. All right? You could just think of it as like if you were to have this, if this were 1 square mile and 1 mile is the length of the side, which is 1760 yards, and then 1760 yards, then that means I'd have to multiply them 1760 times 1760 to figure out how many square yards were in 1 square mile. All right. So then cancel, cancel. So then we're going to do 11,863,808. Divide that by whatever 1760 squared is. And in the end, we get 3.83. My guess is if you did 11,863,808 divided by just 1760, yeah, that answer's there. That's D. All right. So that would be the common wrong answers to, again, forget the square units. And the same thing would hold true if it were cubic units. All right. So they'll give you the conversion factor, or it'll be a one like you're expected to know, like inches and feet or something obvious like that, or they'll give it to you in the problem. But if it's square or cubes, square units or cubic units, you're going to have to do that part yourself. All right. This is another reason why I like to use conversion factors when they give us these units that we would not be familiar with. So they're old units used in Indonesia, so I am not familiar with those. But I can just look at it like this. I don't really need to be. I kind of let the conversion factor do the math for me, like the idea of dimensional analysis. So I'm just going to call this QLOC or QLOC K. And then I know that there is 400K in 29 pickle or pickle, and I'm going to call that P. So then the K's will cancel. And then I know that there are 9P, so the P's cancel in two large Bahar. And that's the answer we're looking for is how many of these L. So now I just kind of, again, I don't need to figure it all out. I just let the dimensional analysis tell me to do 1,000 times 29 times 2, and then divide that answer by whatever 400 times 9 is. Make sure you do 400 times 9 first or put it in parentheses. And you get 16.1 repeating. So I'm going to either stop it there, so I have 5 characters, or if I wanted to do fraction, it's 145 over 9, which again is 5 characters. So either one is fine. All right, on to number 8. So we have 8, here we go, cubic. So we have 8 cubic meters of soil, and we want to know how many cubic centimeters. So what we have to realize again is this conversion factor is not good enough. We need cubic meters, which means we have to do 100 cubic centimeters. All right. Then I'm just multiplying. So 100 cubed times 8, and it looks like it's 8 million. Because 100 cubed is 1 million. Yeah. Makes sense. Whatever one you raise it to, it just multiplies the number of zeros by that number. So 6 zeros is a million. So we get 8 million. All right. So be just very careful with conversion factors in general. And this is the thing to really look out for. These are the types of problems that they know students, especially in a timed environment, are going to make mistakes. But if you go in knowing that, anytime you see square units or cubic units, you're kind of ready for it. Okay. Last type of problem I wanted to focus on tonight was probability, conditional probability. So, what is the probability that a randomly selected student is a female who prefers geometry? So, a randomly selected student means it's out of 200, and then they want that person to be a female who prefers geometry. So, female who prefers geometry is whatever is here. So, I just need to figure that out. Well, if I go this way, the total has to add up to 200, so this must be 80. And then I know that this one here. Actually, I didn't even need that, did I? So if I go here, then this must be 40, so they add up to 120, and then this must be 50, so they add up to 90. So I didn't need that 80. So I get 50 over 200, which is 1/4, which is 0.25. All right, so the key to the problems that we're going to look at is it probability or is it conditional probability? This one is just a randomly selected student is both a female who prefers geometry. They're not saying given that they're a female or if they're a female, what's the probability that they prefer geometry. All right. So when we see that, so let's take a look. I bet in one of these coming up. Um, yeah. So here, if one of the participants is selected at random, the probability that the participant belongs to team A and is assigned to test coffee brand B. Okay. So it's just one of the participants is selected at random. Okay. So that's everybody. So that means my denominator is going to be all of these added together. So that's 8, 18, 24 plus A. And then the probability that the participant belongs to team A and is assigned to coffee brand B. So team A, coffee brand B, that is A. That equals 1/9. And then I've just got a little cross multiplication. My A's and 9's look the same, so that's not good, but we'll just deal with it. So 24 plus A equals 9A. 24 equals 8A, and A therefore must be 3. All right. So again, we do not have conditional probability. All right. It's just one of the participants is selected at random. All right. And then it's team A and is assigned coffee brand B. So that's just the intersection of the 2A table. Now I'm certain the next one is going to be conditional. So it's what I'm kind of setting you up for. So we got 190 people. If a wool scarf is selected at random, well, only wool is selected at random. So we're only looking here. So this is a type of conditional probability. We're not looking at all of them. We're only looking at wool. Then what is the probability that the scarf has a price of at least $21? Well, of these, so of those 75, the 13 and the 44, those number of scarves are more than $21. So at least, so that's 57. And it says express answer as a decimal or fraction. So I could let's see, 57 divided by 75, math enter. Oh yeah, it does reduce. Yeah, I should have known that. So it's 19 over 25. Or if I do 19 divided by 25, I get 0.76. So either answer is fine. Okay, let's take a look at our last one. So if one of the 400 voters is selected at random, so it seems like we're looking at all of them. What is the probability of selecting a voter from state B given? Okay, so the word given is going to be conditional probability. Given the voter is not conservative. So if they're not conservative, then we're looking at this group of people, the liberals, and this group of people, the moderates. Okay, so we are not looking at anybody that's conservative. We want to ignore that part of the table. So then we want a total. Well, the total is 150, 170, 250. So given that they're not conservative, that's 250 people. So we're not looking at all 400 voters. What is the probability that selecting a voter from state B? Well, of these, the 110 are from state B, the 30 and the 80. So we get 11 over 25, which is reduced. So we have 11 over 25, or that is going to be 0.44. So again, either answer is fine. We have enough characters to fit both because we get 5 characters. All right, so look for the word given, or look for them to be very clear that they're narrowing it down to one of the rows or columns. All right, I hope that was helpful, and thanks all for coming and watching the video. And make sure you check us out on TikTok and YouTube, and know that we offer one-on-one tutoring. We have 8-week SAT prep courses. Just call or text, and hope to see you next week.